we will see the implementation of double linked list. Right. So first thing I have to know, again you are doing this using C++. So we will write hash include IOStream, then again using name space std. Now I have to define a structure first. So I will write struct node open close bracket. I have to give 3 variables. What are those 3 variables? Int data is one variable, struct self referential structure, right, star previous, again struct node star next, right. This way you can create a structure with 3 variables. Here in single linked list we are creating with 2 variables, right, data and the next pointer, but whereas in double linked list we have to have 3 variables like this. Now again I have to implement, again I will write the main function int main. Here I have to call the functions. So let us do the insert at the beginning first. Insert at begin, and I have to give the data. Let me give the data as 10. Okay. So we will go and implement that here. So let me take void insert at begin with int data. Okay, because I have to insert a data here. What is the first step? First step is to create a node. Okay, we have to create a node. So how do we create a node? I will declare the node struct node. I will write new. Just let us write new. Okay, now we have to allocate memory for this. So new equal to, using malloc function, struct node star of malloc size of, how much memory I have to allocate, size of memory, how much I have to allocate, size of this node, whatever is the memory size of this node, that much I have to allocate. So struct node. Okay, so what this will do, this will create a new node. Same thing we are doing in single linked list here. See, I am creating a new node, struct node star malloc struct. Same thing here. In a single line also you can do, or no, if you want we can reduce the program length, still we can do this like this. Now I have to see, this is a double linked list. Our structure node contains 3 parts: data part, previous part and next part. By default you have to assign null first. Okay, so this new node of data, I will be putting this data, whatever variable, or maybe for easy I will take it x. Okay, I am assigning x here. So the new nodes data I am putting x. Next, new nodes previous I want to put null. Same way, new node next I want to put null. Okay, these 4 steps will create a new node for me, and it will have both null pointers at previous and next. Now we are doing insert at begin operation. What we have to do here, we have to check whether the head pointer is null or not. We have to check, right, assuming that there is no list at all. That conditions we can do, but now basic implementation we will do, assuming there is a list already. What I have to do here, if this is the only element, what I have to do there, how do I do this? See, in single linked list what we are trying to do, insert at the beginning, insert at begin. Yes, what I am trying to do, we are just making that new node as head. But in here, if that is the case, insert at begin, that new node we have to make it as head. Head equal to new. If I do this, what happened? That new became the head. But we have to check, right, because are there many elements or the single element? Okay, so if there is no element, what will this do? That the new node itself will be head. Okay, now I will do it step by step here. Assuming that there is no element, this is the first time I am calling this function. Let us execute this and see whether it is printing. Let me write another function, print. void, we will do it step by step and see incremental way to avoid no complexity of the program. Void print, what I'll just copy paste the logic, print logic here, display, right, same thing, almost same we have to take it. So yeah, so I am creating a temporary node temp, then the temp I am taking is as head, while temp is not equal to null, keep printing the data, temp of data, and do temp equal to temp next, right. Same thing here also for that double linked list as well, right, but we have to declare the head value, right, struct node star head equal to null initially. Now let me execute and this see whether this 10 is being inserted in the linked list or in the double linked list or not. Step by step we will do the operations. DLL, something wrong here, struct node star new, what happened, void inserted begin struct node star new equal to struct node star, maybe I should not give new. Why? Because new is a function, right, I should not give new. New is a inbuilt function, so it is throwing error. Let me write new node. Okay, this is fine now. Let me execute now. Malloc was okay. Malloc is not defined, so hash include stdlib stdlib dot h. Okay, it has not printed anything, some mistake here. Int x print void print struct node star temp, same thing, right, struct node star temp, we are just displaying the value. No, I have to call it here, sorry, I forgot this, print. Yeah, now I have called this function print. Let us see. See, you are getting the output 10. It means I am able to insert at the beginning. Let me add one more this and see whether it is adding that list, whether it is adding this 20 or not. It will not add because there is one drawback. Let us see whether it is working or not. See, only 20 is coming. Why? In our insert logic, we have to check if the head is null. If the head pointer is equal to null, means initially if the head is null, only then you have to make it this logic, head equal to new node. Assuming what is this case? This case tells us that there is no element in the double linked list. Then head is empty. Then that new node which you just created will become your head. Else part. That's why when I inserted 20 it is failing. Else part, what I have to do here? Now what I have to do? You have to write our step, that is new node, its next should point to head. New node's next should point to head, right, because new node has two pointers, previous and next. That next should point to head, and next one head previous pointer should point to new node, right, both ways. New node's next is pointing to head, head's previous is pointing to new node. Next, third step, what I have to do, that new node I have to make it as head, so your head will become the new node. This way we can insert the element into the double linked list at the beginning using these three steps. Now let us see whether it is printing, see 20, 10. Why? Because I am inserting at the beginning. I got 20, I hope this is visible for all of you. I got 20 and 10. Let us add one more element. Okay, sorry. Now let us add one more element, insert at begin. Let me give 5. So we are inserting at the beginning, so it should become, the list should become 5, 20, 10, right. See, 5, 20, 10. We are able to insert the elements 5, 20, 10. So insert is begin is completed. Now the next one, insert at end. Let us write another function to insert element, void insert at end. I have to pass the variable, I will take another variable y. Again I have to do this mandatory check, these 4 statements are fixed. Why these 4 statements? To create a node, to allocate memory for that and put the value y whatever I am passing and make it null. Again same check I have to do, if that is empty, if the list is empty, I will make the head as the new node. Else, see what I am doing, I have to insert at end. In this case what I have to do, I have to traverse the list. We have to traverse the list. How do we traverse? While temp, for this I have to create a temporary pointer. Okay, so struct node star temp, okay, which is equal to temp is equal to head. I can write in a single line like this. Now while temp not equal to null, while temp not equal to null, what I have to do? Temp equal to temp next. So what will this bring? This will bring me to the last node. My last node will become temp. My last node will become temp. Okay, same thing we did here in single linked list. Insert at end, right? Insert at end also we are doing same thing. So temp of next not equal to null. This logic will iterate me. Okay, iteration is done. I have reached the end. After reaching end, what I have to do? You have 2 nodes now. Temporary is the last node and you have new node with you. So temporary nodes, next node should point to new node. It should point to new node. Then new node, new node's previous value should point to temp. That's it. These 2 statements, temp's next should point to the new node's previous should point to the temp. So a connection has been established now. Okay, so with this we completed insert at end. Now let us see whether it is inserting the elements at the end or not. So insert at end. Okay, so I will be giving some 35 and check. So now in this case, what is the output of this? Insert at begin 10, insert at begin, the list becomes 20, 10, insert at begin 5, the list becomes 5, 20, 10. Now insert at the end 35 means the list should be 5, 20, 10 and 35. See the output, we are able to insert the element at the end 5, 20, 10, 35. You want to add one more element at the end, it will add it. I want to put here 50. Okay, let us execute this. See the output 5, 20, 10, 35, 50. We are able to insert at the end now. Now let us go and write the third function, that is inserting at any given position. Okay, so the function I will write it void insert at some position. I need 2 things here, int the data as well as int the position. I need 2 inputs from the okay. Again this case, you know, this common thing I have to write, and also if new node is null, this I am copy pasting because these 4 statements will create a node for me, right? These 4 statements will create a node for me, and this is to check if the head is null, then make that as the else part. That is the interesting part here in else part. Now this is at position. There exists already a list. See here there is a list already. The list is in order. If I write the current state of the list is something like this. I will comment it. It is 5, then it is 20, then it is 10, then it is 35, then it is 50. This is my current list 5, 20, 10, 35, 50. What I want to do now? Insert at position. Let us say I want to insert at third position here. I want to insert at third position. In this case, you have to go till second position. You have to iterate till second position. So let us assume position is 3. So I will write it here. Insert at position. I have to give the data. Let the data be 25, comma position 3. This is my input. So here let us write the logic. Inserted position. See, yeah. Now what I have to do? I have to traverse till some location. So for that I will use while loop definitely. While some int k equal to 1, k is less than position. K less than k is 1. K less than position means position I gave 3. It means it has to go till here. So 1 then 2. 2 times it has to do it. Okay. Then k plus plus. In this case what I have to do in while loop? Any doubts? Okay. Here what I have to do? I have to iterate, no? Till what I have to do? Simply do temp equal to temp next. That's it. So here we have to declare a temporary variable. Let me give it here. Struct node star temp equal to head. Okay. So temp equal to temp next. This while loop will bring me to this location. My temporary will be at 20. My temporary will be at 20. Now I have this temp node as 20. I have to insert 25 in between 20 and 10. Let us write the logic. Once this is done in while loop, this will iterate and bring me to that but one position, that is position 2. From here what I have to do? You have a new node with you already, right? So new nodes next should point to temp next. It should point to temp next. That is the third variable. If you remember, we discussed pqn. So this is my n, this is my q. I am pointing to q. Next, new node, its previous should point to temp. Second relation is created now. Now this temp next, its previous, should point to new node. Okay, and the last one, temp next should point to new node. Okay, so this is the 4. Just now we have seen the 4 steps, right? Before starting the coding part, we have seen these 4.
Sir, could you drag on this code again while loop?
Should I run this or write it again?
Sir, this while loop, could you dry run it again? Dry run.
Execute it. See.
No, sir, explain.
Okay, see, here this is my current list. 5, 20, 10, 35, 50. I want to insert 25 at location 3. Means I want at this position. I want my list to become like this. After this statement, I want my list to become something like this. Bet 25 here and then like this. Okay, I want to insert it here. When I want to go at position 3, I have to iterate such a way that I have to reach this location, the but one location. That is, I have to reach 2. I have to reach at this location 2. What POS value I gave? 3. So when I give POS 3, K is 1. 1 is less than 3? Yes. Temp of temp next. It will come to 2. Again K plus plus. Again K plus plus. Again K becomes 2. 2 is less than 3? Yes. Temp equal to temp next. Oh, this is going beyond, right? Yeah. Now it should work. So it will reach 2. That way it will iterate. How long should I iterate? I should iterate till I reach this location. Till I reach this location. So this logic will iterate and bring your temporary to point this point 20. Temporary is pointing at 20. From here I have a new node like this. So that new node's next should point to 10. Then new node's previous should point to temp, means 25's previous should point to 20. Then temp next previous. What is this 3 statement? Temp next previous means temp next is 10. Its previous means it should point to 25. That only I kept here new node. And then temp next equal to new node. Let us go and see whether it is inserting 25 at location 3 or not. Okay, I gave Z, no? Sorry, Z. K was not declared in the scope. Why? Token, something is missing. This is fine, this is fine. This is okay. Oh, sorry, I wrote here, sorry, this is for loop, right? I was confused, sorry. This is for, I wrote logic of while, actually it is for loop, right. See, we got 25 at position 3, okay, 5, 20, 25 at position 3, and then 10, 35, 50 as it is. Okay, thank you. Actually, I was confused. I wrote for loop logic, but I wrote while there. Okay, so this way we are able to insert. Now, one more element we will try to insert and see. Insert at position, I will give the element as 55, and I will give the position. See, this is 1, 2, 3, 4, 5, and 6. There are 6 elements. I will give the position as 6 here. Let us see whether it is inserting at 55 at 6th location or not. Okay. See what happened here? I gave 6, but it gave here, oh, I gave wrong. How many elements are there? 1, 2, 3, 4, 5, 6 are there. Acha, I have to tell 7 here. I have to tell 7 here. That's why we can add here. I want it to add 55 here. So when I do that, see, it is not working, right? Some mistake here. When I give 7, k equal to 1, k less than 6. So it will go till which location? Less than 6 means till 5. That is 1, 2, 3, 4, 5. It is coming here and stopping, right? It is going only till that, and this is not working there. Can you tell what is the mistake here? When I am giving insert at 7, right, it is not working. That's why we should have one more check here. K is less than position minus 1 and temp next not equal to null. This both check we have to do. Only then we can go this way. Okay, if this only then we can go at the end, right? So this will not work. We have to write some other logic. If this is 7 means it is insert at the end logic. Okay, so that's why you can put another if condition here. If this is the case, you can have another else if. Okay, if the position is equal to which one? Position is equal to the current length of the no, that is difficult to handle. You have to write that complete logic here. So you cannot give in this, you cannot give as 7. You can handle it. You can write one more else if here. Else if the position is equal to length. So for that you have to always find out the length first. Okay, so that length logic you have to write and then write the value. For now, for time being, let us give some 2, position 2. See, it is inserting 55 at position 2. Okay, so with this we completed 3 functions: insert at begin, insert at end, and insert at any given position. Let's now go and apply deletion operation. Okay, let's delete the element at the beginning. Let us write a function to delete an element at the beginning. So void delete at begin, right? Okay, what I need here to delete at beginning, we can directly write the logic. Again, a mandatory check is there. If the head value is null, the list is empty. You can say that. If you want, we can write it like this: if head is equal to null, then you can print, you can write cout list is empty. There is nothing to delete. Else, what I have to do now? I want to delete at the beginning. What is the logic of deleting an element at the beginning? Right. So, right, deleting at the beginning. What I have to do? You have to break this. No, you have to make this temp's next node as head. The second node we have to make it as head, and delete this, free this. Okay. So for that, I will write. You should have a temporary pointer. Okay, you should have a temporary pointer. Struct node star temp, which is pointing to head, right? So I have just to delete it, right? So I'll write head is equal to head is equal to temp of next. Where is temp? Temp is at the head location. Its next I am making it as head. That is second element I am making it as head. Then heads previous I have to make it as null. Why? When the new node head, always the heads previous will be null only. That also I have to make. Then you have to write free of temp. You would write free of temp. So this will delete an element at the beginning. So let us execute this and see whether it is deleting an element at the beginning or not. So after printing, I will write it again after deleting. Again I will print after deletion also. Okay. So what is my current list now? Current list is something like this. I will have 55 here, no? 55 like this. This is my list. Now what I am doing? Delete at begin means this 5 should be deleted. That's what the expected output. So let us run. Yeah, here there is, let me write some cout statement. Before deletion, and L, same thing after deletion. Now let us observe the difference. Yeah, see here, elements before deletion I have 5, 55 and so on. After deletion, at the beginning see 5 has gone, remaining elements have come. So with this logic we are able to delete the element at the beginning. Next, the next one is delete element at the end. Okay, so void delete at end. Again the same function. What I have to do now? The simple logic. When I want to delete at the end, I have to traverse the entire list. But the important logic is, once you traverse the entire list, you should stop at one location before, but one location you have to reach. See this, how to delete at the end? You should maintain 2 pointers. This is P and this is Q. Okay, you have to maintain 2 pointers, P and Q. Okay, sorry, Q and P also you can say. Q is pointing to but one location, P is pointing to the last node, the one which we want to delete. So that's why we will take 2 pointers here. We will take 2 pointers, one to point to the previous location, because I should have the control of both the locations, the last one and its but one. So we will take pointers here. So I will write something, struct node star temp equal to head. Let's read one more line. Struct node star P is also pointing to head. Struct node, I am creating another variable Q simply. So the P will point to my current one and Q will point to here in this case temp is not required. Let us leave this. Q will be pointing to the previous node. What I have to do now? I have to traverse the list. How long should I traverse? While P next not equal to null. Okay, P is my temporary pointer, it is pointing to the head location. I have to traverse it. While P is not equal to null, in this case I have to write Q equal to P, okay, and P equal to P next. Why Q equal to P means, suppose there are 3 nodes, 1, 2, 3. Okay, P is at 1. Now with this operation, Q will become 1, P will point to 2. Q will become 1, P will point to 2. So with this while loop, your Q will be pointing to but one location, your P will be pointing to the last location. Now what I have to do? Once I reach the last location, simply Q's next I have to make it null. Once I make this Q's next is null, that relation with P is broken. That relation with P is broken. Then other one, which one do I should break? P is previous. P is previous also I should make it null. Where was this P is previous pointing? It was pointing to Q. That also I have to break it. Then simply write free of P. Free of P. So this will erase that memory of Q. Let us go and see whether it is deleting the element at the end or not. Right? So I will just change this end. Okay. So before deletion we will see, and after deletion we will verify whether it is deleting the elements at the end or not. See here. Elements before deletion I have 5, 55, 20, 25, so on, and the last element is 50. After deleting at the end there is no 50, you see 50 has gone, there is no 50 here, right? Only at 35 it is stopping. So we are able to delete the element at the end as well. And the last operation, that is deleting an element at any given position. Let us write that logic as well. Void delete at position. I have to give here position, right, in POS, because I should tell which location to delete. In this case what I have to do, if you want to delete the third element, see this example, if this is my list, if you want to delete the third element, you should have control of the previous element. You should have control of this previous element. Okay, for that this will be my Q, this will be my P. Again maintain 2 pointers. Again maintain 2 pointers. So we will iterate. First we will go to that location while I will take for loop for int k equal to 1, k is less than position. If position is 3 means you have to go till 2. So position minus 1, k plus plus. Okay, what I have to do here, what it should do, q equal to p, q equal to p. I have to declare those things. I will just copy paste these things like this. Okay, q equal to p and p equal to p hyphen next. What will this do? This for loop will actually, in this example if you see, this 20 will become my q, 10 will become my p. 10 is the one which I want to delete. 10 is the one which I want to delete. Okay, so I have reached the position. Now what I have to do? What is my logic? What is my actual business logic? I have q, I have p. I have to remove this. I have to remove this 10 from the picture. So we have to, 20 should point to 35 and 35 should point to 20. 20 should point to 35 and 35 should point to 20. Let us write that logic. 20 means q. Q's next should be your p's next. What is p? Where is p? P is here. What is its next? 35. So 20 to 35 link is formed. Now 35's previous should point to q. So it means p next its previous, p next its previous should point to q node. So with this we formed a relation like this, 20 to 35 and 35 to 20. So this 10 is gone, broken now. Okay, this 2 over, because q's next is pointing here, its previous is pointing. Now I have to just free the pointer p. Let us see whether it is deleting at any given position or not. Just I have to change the position, right? So I have to give position and let me give 3. Okay, let us see whether it is deleting the element at third location or not. If we observe the output, see we have elements 5, 55, 20, 25 and so on. It is deleting 55, no, here position, yeah, see the element at third position is deleted now. 5, 55, 20 was the existing list. I want to delete the element at the third location. I want to delete the element at third location. See, 20 is gone now. After 55, I have 25 only. After 55, I have 25 only, right? So, this is the implementation of double linked list. Okay, insert at begin, insert at end, insert at some position, again delete at position, delete at beginning, delete at the end. Okay, same thing as your single linked list, only thing your structure will have 3 variables here: data, previous and next. Okay, so you can again, like I said before, you can write a menu driven program. Here you can write a menu driven program.
Sir, how can we reverse the list?
Okay, the third one is reverse. Suppose I want to reverse the list. So let me write the function void print reverse. Okay, I want to print the list in reverse order. Okay, now see, in double linked list, to reverse the linked list, there is no direct approach. You have to go front and come back. That is the only logic. You have to go front and come back. So for that, you have to traverse till the end first. You have to traverse till the end means delete at the end. No, here you are traversing till the end. So I will take. I have to reach end first. For that, what I should do? I will take a temporary pointer, struct node star temp. Let it point to head. I will write my logic while temp next is not equal to null. This will, what it will do? It will traverse me until it is null. I will write temp is equal to temp next. So this will bring me to the end. These two lines of code will bring me to the end. From there I have to start printing. How I will write? I will write one more logic while temp. Okay, temp's previous not equal to null. Temp's previous not equal to null. What I have to do? I have to see out the temp's data. See out the temp's data, and I have to move temp equal to temp's previous. So what I am doing here? I am at the last node now. I am checking if its previous is null. Not null, print that data, move back. Temp to temp previous. Until that is null, you have to keep moving like this. So it will print the temp data. Let us put here NL. So this will print the temp's data. So let us see whether it is reversing the list or here. I will write again. This is elements in proper order. Okay, I am deleting this also. Let us comment that, no problem. Here I want to print element in reverse order. I will call the function reverse. Let us see in reverse order. So I am doing some operations. We will get the element in one order. We will see it reverse. See the output here. Okay. Again, there is one delete operation, because of that it is happening. Let us ignore this. Yeah. Elements in proper order 5, 55, 20, 25, 10. When I do reverse, you see 50 has come, then 35 has come, then 10 has come, then 25 has come, then 20 has come, then 55. 5 is missing. Why 5? Some logic mistake here. I have to do temps not equal to null. This way if I do, we will get, yeah. See, 5, 55, 20, 25, 10, 35, 50. In reverse, 50, 50, then 35, see, 35, then 10, then 25, till 5. We got this in reverse order. Okay, but what is the, again, it's a drawback only, no, going front and then coming back, it's a drawback, I understand. But if suppose after doing certain operations, you are at the end location, from there you can come back. Instead of writing this once again, you can come back. Okay, so this is the implementation of double linked list.